Sorry. Tomorrow. You got it tomorrow. Alright. No questions on vertical surfaces?
No. Well,
Anybody want to ask a question?
Wait, I can't think without my pen. Wait, no, it's stuck.
100% on the S. Made in Mexico.
How
Why
much was
was
that?
it? It was like 140 something for the basic test.
Hey guys, we gotta go.
Oh.
We're gonna go back to the plain peanut M&M stuff today, so don't sweat that if you have a question. We're gonna look at the check your understanding from 7.3 in a second.
Oh, we're supposed to do that?
Yep, that's part of that email.
Oh, we were part. I thought I just did the homework.
If you did the homework, that still tells you whether you know how to do it or not. So, guys, remember, I need y'all to do something to see if you know what you're doing.
That's right.
See what questions you have. Never. Just to anger you. Alright, any stats related questions? Not clock related questions. Alright. So, we are going to get back into looking at differences in sample proportions, and then we're going to get into sampling distributions with means today. So, I finally actually put the FAIR models in there. By the way, or not FAIR, proficiency scales. Ms. Kowalski is going to make scans of proficiency scales that I did for each of you, because I did a hard copy that I'm going to scan and put into the Google Drive. But, what I want y'all to hear me on is this. There's a root or a scale that I'm supposed to use to convert from average proficiency scores to your final grade. What I'm going to end up doing is I'm going to scale those for now. It's open. What'd you forget? Okay. I'm going to scale those for now because here's the reality. When do you need to have completely mastered those proficiency ideas?
By the AP exam.
By the AP exam, right? So I don't want to punish you if you haven't completely mastered them by the end of the third 9 weeks. So I'm still going to put in a proficiency scale grade, but I am going to be very nice on the scaling of those things. So push the door. Just kidding, he closed it. So for those of y'all telling people how difficult Mr. Kinney is, be aware I'm also going to be really nice to you on those proficiency scale things. Michael smiles instantly because he knows he's one of them.
That AP stats, whatchamacallit.
Oh yeah, I tried to convince Amy Holland to do AP Cal PC.
Yeah, how'd that go?
I don't know, she nodded and smiled.
Nah.
I think she just wanted me to
She
get
don't like
her
you.
though.
She don't like you.
Because like I put like my arm around her shoulders and I started walking with her.
Anyways, but all that to really say, because what I want to end on is this. What I want us to understand, and I know it's difficult to remember this, but what is the point of school?
To learn.
To work out your brain.
To work out your brain, to learn, to master.
Prepare for your food factory.
To prepare for my job in the factory.
How many of you mentioned a grade there at all?
With grades.
Okay, so here's the thing. I always have to find a balance, and I need y'all to understand that there is a balance of like, the grade needs to reflect how much we have mastered and understood, but also I think you should have many chances to understand. That's why some teachers are going to give you an assignment, you do it once and that's it. But I'm not that way because I'm not just giving you an assignment to do an assignment, I'm giving you a chance to learn. I'm going to give you feedback to grow and to learn, okay? So I know things are difficult for some of us and I know that we're moving quickly at times, especially because this block sucks. But I'm pushing you, I'm leaving it open because Ms. Paulson can come in. I'm pushing you because all of you are capable of mastering these ideas, but I'm going to hold you accountable to mastering those ideas because the learning is what matters. I'll sign whatever grade change form I have to as long as I have evidence that you have mastered. But we got to get on top of things and earn those grades that we want. Okay? So, let's get on top of these things, ask those questions. Oh, sorry, Chris. There you go. Thanks, sir. So, I'm giving you these proficiency scales back, or my copy of these for you so that you can see what I've seen mastery of, so that you know what you need to study, and you can come in during advisory to show me mastery of just individual skills at times. Talk through ideas, show me mastery that way. I need us to master these ideas so that we are ready for that AP exam, because that's the culmination of all this. One, every single one of you plans on going to college, and it'd be great for you to have 3 less hours to do, 1 less class to do in college. And even if you're looking at it like, man, I don't need this for my major, at the end of the day, you can always use it for an elective. So we want to make sure that we have mastered these ideas, okay? So let's learn, let's grow, and let's get going with it. So these are the proficiency scales for what we are currently working on foundationally. We should actually already know most of this. The only real concept that I'm looking up here that we haven't studied yet is something called the central limit theorem. The rest of those ideas look pretty familiar, don't they? On the Unit 4 proficiency scale. Hey guys, do that on your own time. We got to focus up here so that we can move forward, okay? Central limit theorem. Anything else in that section that we haven't heard before? That's about it, right? Everything else is... What?
Wait, I thought the independent samples 10% condition is the same as the large count condition.
No. Good, I'm glad it was... Okay, so, independent, so 10% condition says what?
If the population, like 10% of the population is still bigger than the sample.
Right, so if your sample size, little n, is less than 10% of your population size, then you can treat your sample as independent random samples, okay? What was the large counts?
If the expected number of successes and failures is greater than 10, then it's binomial, or you can.
It's
approximately normal.
Approximately normal, right? So remember that applied to binomial distributions, telling us it's approximately normal, which when we talk about proportions, it's either a success or a failure, right? Like when we talk about those proportions in sampling distributions, those are binomial, so when are they going to be approximately normal? With large counts. So certainly that may be because there's a 10 in both of those, but when the sample size is less than 10% of the population size, that's when you need to, or if you're sampling without replacement, that's when you have to check the 10% condition.
Okay.
This is if you want it to be approximately normal, okay? So we still need to work on this, and we're going to actually look at that right now. Yeah, we're going to get to actually most of that foundation in a second. We talked about a lot of the big principal ideas. Now we're about to get into, I know this looks like a ton, but there's some things I need to add in. But just determining parameters of a sampling distribution for sample proportions. But where can you find equations or formulas for that? On a formula sheet. Determine whether a sampling distribution can be described as approximately normal. What is that?
large count.
That's the large counts condition, right? Now we need to work on interpreting probabilities and parameters for sampling distributions. And then we are looking at the difference. So we're getting into a lot of the actual doing of the things today and tomorrow. So here's the recap of notes from 7.3 that I just want to quickly go over before we do the check your understanding. So again, this is what we were talking about, shape. So the shape of a sampling distribution of p hat is approximately normal if it satisfies large counts condition, right? The center, so the mean of all my sample proportions, please notice I don't just read mu p hat, I read what it means. The population mean, the mean of what? What is p hat?
The sample proportion.
So the mean of the sample proportions is equal to which proportion? Population or the true proportion. Why is the mean of the sample proportions equal to the population proportion?
That's not mean they're built. That's like the numbers all add up in the end. If you know what I mean? You can't find it.
There's something really important that you're forgetting about p hat. It's not just an estimator. It's not just a statistic.
It's an unbiased estimator.
It's an unbiased estimator. Don't forget, p hat is an unbiased estimator. And remember, when we say estimator, we mean statistic. It's an unbiased estimator of p, right? P hat is an unbiased estimator of p. And the whole definition of an unbiased estimator is that the average of the unbiased estimator is the parameter. That's the idea there. Okay. But even if you don't remember all that background, where can you find this formula? Formula sheet, it's on there. Guys, on this unit and every unit from here on out, you want that formula sheet out 24/7. Yeah, even when you go to sleep at night, you want to sit underneath that pillow, let it sink in through your brain. It's a joke, Serena,
I used to
golly.
sleep with my fish boat.
It's a joke, why is it not funny?
Oh!
This trauma from my neighbor.
I remember that.
Actually.
Okay, variability, the standard deviation of p hat is the square root of p times 1 minus p divided by n. Remember, that actually came from the binomial standard deviation. And so notice right here, that's where you check 10% condition if sampling without replacement. So if you sample without replacement, you check the 10% condition, right? The last thing I do want to point out, because I'm going to come back up in a second, a lot of students try to memorize this formula right here. That's heinous. There's a whole lot of formulas like this that you would have to memorize. Start at the beginning. Start with what the formula sheet gives you. What does the formula sheet start you off with?
Statistic minus parameter over standard error.
Right? So that's what the formula sheet has, right? And then we need to recognize, hey, we're dealing with sample proportion, so what is the statistic?
Yeah.
P hat. So the parameter is going to be the mean of p hat. Parameter is always a mean of p hat, right? Standard error, that's going to be the standard deviation of p hat. So p hat, mean of p hat, standard deviation of p hat. Then where can I find the formulas for these two things? On the formula sheet, right? That's where this final thing comes from. So if you can identify what your statistic is and you know that you have a sampling distribution, write it out from the formula sheet and work it out from there, okay? I'm going to ask a student to memorize all of this. Some of us will, naturally, and that's totally fine. But instead, learn the fundamentals, learn where to start, and substitute in what is literally given to you, okay? So keep that in mind. You gotta go for that, yeah.
Why is,
Go for it.
okay, I'm trying to like do the check your understanding thing. Why is the p hat and the p not the same in this? I don't know.
So remember, what does p hat stand for?
Statistic parameter.
Yeah, but like p hat, because it's a statistic, it's a sample proportion. What is p? P is my population proportion. So are they usually going to be the same?
Yeah.
She's grading.
No?
Does anyone remember why the sample proportion is not usually going to be the same as the population proportion?
Because it's not all of the population?
Sampling
It's not the population, because of what?
Sampling variability.
Sampling variability. Remember, right, like right over here, which you can barely see it, right? There's my parameter, there's my mean, right? Okay, were most of those dots perfectly hitting the mean?
No.
No, it was centered around the mean, but remember each sample is a little bit different, right? So there's sampling variability, and that's an important component of statistics for the unit we're about to get into. So A just says calculate the mean and standard deviation of the sampling distribution of p hat. So A, what is the mean of p hat? 0.08.
It's 8%.
Yeah, 8% of all, right? So it's my p, right? Standard deviation of p hat then.
0.08 times 0.92 over 1,000. Just get rid of that.
So p times 1 minus p divided by n, and then square root of all that. I don't know what that comes out to be.
0.0085.
0.08.
0.00858.
There we go. That's just plugging into a formula. Okay? I will say, if you write out the formula, you know what that helps you do? Not make a mistake, right? If you just take an extra second, and by the way, is this a formula you have to memorize? Heck to the gnaw, right? You just gotta look at the formula sheet. If you know that you have a sampling distribution of p hat, look at the formula sheet. There's my mean, there's my standard deviation formula. Don't make it harder than that. So is the sampling distribution of p hat going to be approximately normal?
Yes.
How do we check that, Lana? Okay. I'm gonna come back to you in a second. Someone help us remember how we check it. Sprig.
So you do the n times p, so you see if the number of successes is more than or equal to 10.
So the expected number of successes, right?
Expected number of successes. And then you do the same for the expected number of failures.
Okay. What is this called again, Lana? Remember? Large what?
Counts.
Counts condition. Mhm. Does anyone know why I keep saying expected number of successes and expected number of failures?
It's like the same as like approximately normal, you can't like say for sure, and
I mean,
this
it's
is just
just-
sample, not.
Or,
Well, and remember, this is actually based on the population, right?
Uh-huh.
That's what we'd expect to see. Why do we not necessarily see that? Because it's something Peter said earlier. Don't say it, Peter.
Sampling variability.
Sampling variability, right? Like that's what we'd expect to see in the
long.
long run. There we go. Law of large numbers in there. So we expect to see in the long run, but it's not what we're going to see every time. That's what we expect to see. So is this going to be approximately normal?
Yes.
Not probably. Yes, it is approximately normal.
I knew what you were saying.
So this satisfies large counts. C, find the probability that the random, oh thank you so much, that the random sample of 1,000 adults will give a result within 2 percentage points of the true proportion. Now I need y'all to lock in on this because notation is killing me with some of y'all on probability. And second, we got to recognize a couple of things about this one. So first things first, what are we dealing with in C? Something you've dealt with lots and lots of times at this point. Say again?
Normal
Yeah, we just showed that it's a normal distribution, right? So we're looking at some kind of normal distribution. You know, all my purple bits right here.
Oh, the top here.
Shh, I don't need that. It's actually not. Wow. I thought the same though. Okay, so it's got approximately normal distribution. There's my normal. So what's going to be right here in the center?
0.08.
0.08. And what do I now need?
The z-score of
The standard deviation, well, yeah.
Oh.
the z-score of 0.06 and 0.
I was saying, because I would even just mark it on here. I don't know exactly where it's going to be, but I know 0.06 and
0.1.
0.1, right? Like it's got to be within 2 percentage points.
Or like
And you're right, I need to convert these to what?
the z-score.
So what I want to know is what is the probability? I'm going to show this notation in a second. You don't have to use this notation, but what I want to know is what is the probability that 0.06 is less than my p hat is less than, what does the p hat need to be less than?
0.1.
0.1. I just want y'all to see this notation because this is my input. That the random variable is on the inside. What's on the outside at the very end is my true, or is my probability. Now what do I need to convert this to make my life easier?
Z scores
Okay, so z is equal to,
P hat.
minus 0.08, like 0.08.
I'll get there eventually, but I'm not doing that yet.
P hat minus P
So p hat minus p,
over standard.
then over what?
No, standard.
Standard error, and what is the standard error here? So if you remember, I wrote this earlier, I would start with p hat minus the parameter, mean p hat, divided by the standard error of p hat. I would write this formula out every time. Now we go to my formula sheet. What is the mean of p hat?
0.08.
Well, you're not wrong. What is it though?
The population.
So p, population proportion. No, you're right, like you're just jumping ahead. I'm just trying to get us to recognize the formula so that we can substitute things in. What is the standard deviation of p hat? Not in this problem, in general, for any sampling distribution of proportions.
Square root of p times 1 minus c over n.
But I just wanted us to slow down and see that detail in there. Alright, so p hat 0.06 minus 0.08.
I'm so.
What's up?
I was trying to calculate the z-score without putting the 0.06, and I was so confused.
Yeah. Notice the whole thing is we're converting this to a z-score, right? Yeah. You definitely need that.
Oh, tell me where that came from for 0.06.
So go back to the problem. Where did we go? Within 2 percentage points, right? So what was the percent? So what's within 2 of 8? 6 and 10, right? So that's all we did. Now I will point this out. I actually don't have to write all this out because didn't we do this work earlier? No, so tell me what those z-scores are. Convert those to z-scores for me.
-2.309.
Oh my gosh. That was so quick.
Cause I already did it like a bit earlier.
Oh, so you're try hard.
Not as much as you, Serena.
Negative what?
2.331.
Okay, I want y'all to make sure everyone is getting that z-score. Alright. I will
Should it be
point
the
out.
same but positive for the other one?
Right, because, why do we know that this is gonna be the same but positive?
This
So
is
we're
the
at
distance from me.
Cause it's what?
They're both
Same
one
distance.
exact
Different
deviation away from
Or whatever.
Yeah, I was just gonna point out because a normal distribution has what starts with an S?
Symmetry.
Symmetry, there we go. Alright, make sure you're getting that z-score and then find that probability. If you're not, let me know. And some of us need to make sure we know how to find that probability. Why did you get that z-score? Ah, okay. You got your calculator out so you can do that, because you need to practice doing that calculation. You need one?
Thank you.
You need to borrow one and take one home for me. Now, hold on one second. These are what kind of numbers? What did you label them as?
What?
What letter did you use right here?
What's going on?
What's that letter?
Z.
Okay, so these are z-scores.
Okay. Wait.
They no longer have this mean and standard deviation. When you convert it to a z-score, the mean is what?
One. No. I don't know. What?
Yes, you do.
What's going on?
What's the mean? And the standard deviation is, the whole point of z-scores
Yeah.
is our mean is 0, standard deviation is 1. Okay?
Yeah.
Yep, is to make your life easier. I promise you. Alright, what are you looking for? Oh,
I know the geometric RAM together before, I just messed up on the test, remember? I literally told it to you.
okay, then show it to me a little bit later and then we'll get it marked off.
Okay.
Okay, like that's the thing. I'm giving this to you so that you know what to say, hey, Mr. Kenny, I can do the dang thing, okay?
Okay.
Alright, so what's our probability?
0.98,
0.
0.25,
0.98.
0.25.
025. Okay. What you looking for, Luana?
Okay.
Okay. You sure? You should get that those z-scores in the area. Okay. Quick point of order. Why should that probability make sense based on something else we have learned this year?
Because of empirical rule,
What about that empirical rule?
that like everything in the middle will be crap ton.
Well, if we are between 2 below and 2 above, what percent of the data is that?
Like 97.
95%. What's within 3 standard deviations?
99.7.
Okay, right, remember it's 68, 95, 99.7. So that 98% makes a ton of sense. Okay? Alright. Say again.
I was wondering if
Like
I
to find
like,
the,
do
like
something
the,
like that with
Okay,
calculus.
so you would do like.
Like find that area with calculus?
Yeah.
Yeah, you just do an
Yeah, I know,
integration.
like random.
Mhm.
Oh, I gotta get
Well,
No,
just-
but like find the percentage.
Yeah,
It-
just find
so
the, use an
Area
anti-derivative.
divided by like total area,
Mhm. Just integrate. Integrate from 0.06 to 0.1
So you would go to
with the definition of the
right?
function.
No, I
Alright,
meant like a percentage.
And then go with it.
I don't know.
Like it gives you a percentage.
Alright, we gotta move to D. If the sample size were 9,000 rather than 1,000,
Because it's.
how would this change the shape, center, and variability of that sampling distribution? Hey, Peter and I, hold on one second, go and keep talking about that in a second. Right here, D though, if the sample size were 9,000 rather than 1,000, how would this affect the shape, center, and variability of the sampling distribution of P hat?
It wouldn't
Shape's the
affect
same.
the shape.
the mean.
Why would it not affect the shape?
The shape don't
Because
change
it's
the
resistant.
transformations.
Yeah, it's just divided by,
Kind of. It's, there's another reason why the shape wouldn't change here.
I mean, if every value is like multiplied.
What if this? If the sample size went from 1,000 to 100, that shape would change. Why?
Because
Spread.
Has nothing to do with spread.
Like, so that's reflective of the population?
Variability.
the
Oh,
range would change.
What did
Because there's just less.
Large
Hey,
counts
what is
condition?
It's
Oh, say that again.
Large counts
The large
condition.
counts condition, if I do
Oh, yeah.
100 times 0.08, I get 8. That violates the large counts condition. That distribution would be skewed right, okay? So, it's not that the shape wouldn't change because multipliers don't affect anything, because the shape could change if we no longer satisfy large counts. But if we get a higher sample size, will that still satisfy the large counts? Larger sample size, Michael?
Oh, yeah, no,
Yeah.
sorry, I meant smaller.
Yeah, smaller no, higher, yes, 100%. So the shape will not change because we still satisfy the large counts.
condition.
When we talk about shape with p hat, we have to always think about large counts condition. Will the center change because of a higher sample size?
Yeah. I mean, the mean number will change, what do you mean?
Well, the expected number will change. But remember, what they're asking about is the mean of p hat.
Oh, it's the same.
What does that equal? That equals p. Does it care what the sample size is?
No.
No. Remember, so Serena, look over these distributions that we already did. It didn't matter how large the sample size was, did the mean of our sampling distribution stay the same? What changes as our sample size increases? Variability, that's it. I need us to remember the shape can change based on large counts condition, but the higher sample size, lower sample size does not affect center, but it does affect spread. Does anyone know how much increasing the sample size to 9,000 would affect the spread? So one is going to make the spread what? It's going to make that spread decrease. Anyone know by how much?
It's in the textbook somewhere.
Say again.
It's in the textbook somewhere.
It might have been somewhere in the textbook, yep. I want you to think about this.
9 whole
Oh, is it like 1 over the square root
Oh,
of?
because it's over the end.
It's divided by n, but what have we done to our sample size? We multiplied it by 9.
So changing
Times by
by
3?
So
0.09.
notice how we're taking the square root, right? What's the square root of 9? 3. So because it's in the denominator, the spread is going to be a third of what it was. Like you can actually substitute the 9,000 into here. Can someone type 9,000 into that? Type 9,000 into that.
When you said someone, I thought you
I meant everybody in the club.
The clerk.
Oh, the clerk.
The
We all, we all.
You need to practice.
And the clerk.
We all fan.
What?
What did you get?
0.00285.
And if 00285. And if you hadn't finished, keep typing in, just because Serena got it doesn't mean everyone else is done. I want you to think about it. Is that roughly a third of this?
Yes.
Yeah. If you take 0.28 and you multiply it by 3, you get 0.84, and it's just a little bit more than that because of that extra 5 there. So please notice, we need to recognize that when we increase our sample size, it makes our spread less, and we can figure out exactly how much less by taking the square root of however much it was multiplied by. So if we quadruple our sample size, what's that going to do to our spread? It's going to make it half, right? The square root of 4 is 2, so it's going to make it half as much. What are your questions through this check your understanding?
Lisa, can
Yes, ma'am.
you show me how to do the problem on a calculator?
Yes, 100%. We're going to do some more in a second, so I'm going to come back and check with you on that, then don't let me forget. Yes, Serena.
So, say D was asking for like a transformation rather than like the sample size increasing, like how would you?
A transformation would not change the shape.
Or explicitly say it, like,
Yeah.
okay,
It'll say that you're transforming the random variable,
Alright.
not that you're
sample
changing the
size.
sample size.
Okay.
The sample size is what's changing there. Okay, so we got to here yesterday, and I realized, we started talking about number 4 here, and I realized the reason I was a little off is because we should have just used the data that they had and we'll talk about why in a second. So looking at, and then we'll come back to our data, but this is the data that they gave with Mathematic, and they did M&Ms and Skittles, but I'm personally all about the chocolate. I don't like Skittles that much, so
What?
M&Ms and what?
You don't like Skittles?
I said I don't like it that much. I mean, I'm a fiend for sugar, but I like chocolate better. So here's the sampling distribution that they did. So first off, what's the shape of their, and also I wanted to use theirs because they had more data. We couldn't quite see our shape with theirs. What's the shape of that distribution?
Unimodal.
That is, so what'd you say?
Unimodal.
It is unimodal, but what's something even better that we could say? Approximately normal. Are you looking for our data from yesterday?
Yeah,
Great point. I should put that up.
like where's all M&Ms?
Yep, yep, yep.
Do we add data, like this data onto the graph?
I don't know why all this is here. That was a mistake on mine in this whole part. What was your question?
Are we putting that on our paper?
Are you putting, no, just leave it,
Bruh.
leave your paper as is.
Are you so for real?
What?
There's no on that.
Oh my god.
This data's on my computer.
That's not allowed. He's behind using them.
That's so sad looking.
He's right behind
What?
us.
Our data.
Oh, that was for a different thing. Yeah, the amount of data we have? Yep, sad. Okay, so the shape here though was approximately what? Approximately normal. What is roughly the center of their data?
Around 0.04.
And there, yeah, let's use ours though. What is the, for the center at least, what's the center of our data roughly?
Like
3,
zero.
7, 8, 9, 4,
No, actually,
1,
Like
2,
mean
3,
or
4, 5, 6,
median?
7,
Mean.
like 0.02.
Oh, yeah.
8.
And I might even go, if we're gonna say approximately normal, the mean and median should be roughly the
Same.
same.
Well, like, I feel like there's a potential outlier at negative 0.12.
Yeah, but I could see that, so that's what I was saying, if we're just gonna base it off the idea of it being approximately what?
No.
Normal. And what do we know about mean and median when distributions are approximately normal?
They're roughly the same.
They're roughly the same. And that's gonna make our job easier, Serena, that's the only reason why I'm going off that. So roughly, based on that, what should our mean be?
0.01.
0.01. And again, this is an about. About 0.01. What does it look like our spread over there might be? And when I say spread or variability, we're talking about standard deviation. What do you think that standard deviation might be about?
Hold on.
Like 0.82.
0.82?
Like 0.3, 0.03.
I can't tell. I
How
can't
can
see
y'all
how
see just by looking at
like I
it?
can't tell how
Like,
much that
hello?
is.
So my estimate is probably 0.03.
Wait, never mind. Wait.
Right, so 0.01 to 0.04, so about 0.03. I don't know for sure. Again, these are just estimates. But that's my estimate, roughly, for the
Wait,
standard
that's
deviation.
oh, never
Because
mind.
remember, what is standard deviation?
I thought that was a 1, not 0.1.
Oh. What is standard deviation? So the average distance of the data points from our mean. And if you have and here's the other thing, Serena, I will say it's harder to see when it's not normal, but when it's normal, how many standard deviations do you have to either side?
Like 3 times.
3 to either side. That's kind of what I'm thinking about is 1, 2, 3. See what I'm saying? So that's how I kind of estimated that. So keep all of those ideas that we studied in the past in mind when we talk about this. So all that to now, we're just, and we're not going to look at, apparently I forgot to update where it says Skittles. This is supposed to say peanut M&Ms.
Right.
Because they're better.
Right. No, they are. No, they are.
They're okay.
Fight you. Okay, so using ideas from the previous lesson, describe the sampling distributions of p hat for M&M's X and size 50, sample size 50, and the sampling distribution of p hat for peanut M&M's for samples of size 50. Do notice, I not Googled this, I had to go all the way to ChatGPT who found the source, but 25% allegedly, of plain M&Ms are orange, and 22% of peanut M&Ms are orange. So,
Scandal.
I know!
It's probably more expensive.
The disrespect. Regardless, I need you to find the shape of the plain M&Ms. Work with each other quickly. Find your mean and find your standard deviation. I'll explain why I need these in a second. So, 4 minutes, max. Huh?
Do you know the banding red 40?
Good.
I don't understand.
Oh.
Doesn't it increase staining?
I ran 40.
No idea. So, where's your
I
package?
My talkies,
My talkies.
I don't like talking.
What are we on?
The back of the nose.
So, remember, you need to start. And by the way, talk with each other, find that shape, the mean, the standard deviation quickly and efficiently.
Oh, I'm okay.
Right here. Notice how we found these z-scores. So, we know, can I see your pencil real quick? We're shading, we're trying to find this probability, yeah? So this is the lower bound of what I have shaded. This is the upper bound of what I have shaded. Now you converted them to these z-scores. So my lower bound for the z is negative 2.331. My upper bound for the shade is 2.331. Because we have converted the z-scores, the mean is 0, standard deviation is 1. There you go. So we had these were our p-hats, right? Lower bound, upper bound. And then we substituted everything into this formula to convert it to a z-score. So p-hat, p is my mean. And then be careful, it's the square root. Because remember, if you look at that formula sheet, the mean of p hat is p. The standard deviation of p hat on your formula sheet is the square root of p times 1 minus p, all divided by.
Oh, okay.
Yep.
Okay, thank you.
Yeah.
Yeah, just, talk around this.
Yeah, so remember you have, if you look at the formula sheet, sampling distributions, and this is the one for proportions, right? And so you can find your mean and your standard deviation there. Don't look at the two populations, just look at one population for now. Because we have one population here, one here, okay? So, let's just talk about shape. Make sure we're all on the right path. What do we need to check to determine the shape of these?
Large count.
Large counts, right? So, what's the sample size? So, 50 times 0.25 is what? But more importantly, what is it?
Above 10.
Greater than or equal to 10. Right? What else do I still need to do?
0.75 or 50.
I mean, if you do 0.25, you know that 0.75 is gonna be bigger.
I'm glad you caught on to that. That's something I brought up to other readers and table leads at the AP exam. You can say, here, so let's do this really quickly, because it can get tedious when you have two populations like this, right? And so so was it 50 times 0.22, which comes out to be,
11, I think.
Yeah, it is.
which is greater than or equal to 10. And so it can get tedious to do both, but you still have to make an indication that you understand that both are greater than or equal to 10. So you can either do it again for the expected number of failures. Now, what I will point out is, you don't have to do all this work again, because if the expected number of successes is 12.5, what's the expected number of failures?
Okay,
37.5.
Remember, it has to add up to
50.
50, right? So successes and failures have to add up 50. So you either need to write that out or say, we
Can I
checked the lowest.
Could I do like 50 minus 12.5 equals 37.5 is greater than 10?
Say that one more time.
50 minus 12.5 equals 37.5, which is greater than or equal to 10.
Yeah, I would just write this though and just that.
So is the free response still like handwritten?
Yeah, it is.
For stats, it is.
I looked it up, it said it's a blend, so the MCQ will be online.
Yeah, that's true.
So we should probably start practicing. Because
Mhm.
Bio's gonna do that later too.
Oh yeah. Bro, we haven't practiced writing essays online yet. I know you guys have.
Yeah.
So what do we know about both of these? So both are approximately normal by what?
Law of large counts.
By, not law of large counts,
Large
Large
counts.
large counts condition. Be careful, I know there's a lot of vocabulary, but law of large
Nope.
Numbers.
numbers for probability, okay? Do we need to wait a second for you to do mean? By the way, I do want to point this out, notice how I'm using P in both of these? That could be problematic.
P1, P2.
So, let's say P1 equals plain M&Ms, P2 is equal to peanut M&Ms. When you use symbols like this, you have to define them. Okay? You could even just use actual words and it'd be much more plain or clear, but it can get cumbersome. So I understand. Ideally, I would use a single subscript, but
Why can't you just do peanut and like subscript nut? That'd be so funny.
that'd be fun. You go for it. You do you.
Peter, don't take my idea.
No, please steal her idea.
Oh my.
Yeah, I'm not gonna do that because I'm not a colonizer like her.
Oh, alright, so the mean. Moving away from that, what is my mean?
0.25.
How'd you get that?
Because
Because it's equal to P.
Mean of P1 hat is P1 equals that 0.25, right? It's just equal to the population proportion. What is the mean of P2 hat?
0.22.
And how'd you get that?
Same thing.
Because it is equal to population proportion. Remember, where can you always find those formulas? That formula sheet's got so much good stuff on it. So what about my standard deviation?
0.25 times 0.75 over 50 square root.
It's interesting to me that you say that square root at the end.
Because I do it
Yeah.
last in my calculator.
Well, if you're gonna do it that way, just do it to the 1/2.
I'm doing all that.
Where it says
I'm
square
doing
root
what works for
before.
me, Jaden.
Yeah, she can do what she wants.
Well, I'm just saying,
I'm just saying too.
to the 1/2 is
Let her
better.
live her life.
To the 1/2 is
You're
better,
her
unless
boss.
you wanna add
You
the
think I'm gonna remember
square root
that?
to the end.
I do like raising it to 1/2, and if you take, when you take calculus, you do want to remember that the square root is the same thing as raising it to the 1/2 power. I will say that. You
Oh
need
yes,
that
I
for
love
calculus.
doing that. That's so
Yeah.
much fun.
So,
We don't
Oh my god.
alright, so what's my standard deviation there?
0.06124.
0.06124?
You're really good at remembering long numbers after like someone yells them out.
Sure.
How much?
No.
You like number.
I only have 3.1415926.
That's embarrassing.
What's the point of having more?
Just a lot of hatred.
What if you wanna work it like Lockheed Martin, and like
I don't.
build
Oh,
like a.
I know.
Okay, what's the
someone
second standard
whose
deviation?
mom is a
0.05858.
at Lockheed
0.
Martin.
What?
0.5858.
I might get a job there.
Okay.
That should be funny. We're
Alright.
starting here, that's the legal bonds.
Hello.
So, now let's use this. So what would the sampling distribution of the differences between proportions be? What shape would we have?
Still approximately normal.
Still approximately normal. Why?
Because you're just combining them and they're both normal already.
I need you to pay attention to that language. What did Serena just say? We are combining them. We essentially are combining random variables, right? And if the two distributions are approximately normal, the combination will be approximately normal. We need to understand that idea of combining random variables. Okay, so I'm going to erase this part just right here. So because both are approximately normal, the sampling distribution of the difference in proportions is approximately normal. So what about the mean of the difference between proportions?
Formula sheet,
Formula sheet,
or just add them.
but also let's just look right here. What should the difference be? So it should be 0.25, right? Minus 0.2, which is 0.03, which we're a little off from that. Any guesses why we were a little off from that?
Variability.
Variability and also
Numbers.
law of large numbers. Did we have a lot of numbers here?
Nope.
Nope. We had very few numbers.
We had 9.
Did that affect things?
Maybe.
Yes.
Yes, very much so. But notice this is just the mean of P1 hat minus P2 hat. I believe that's on the formula sheet. What does the formula say?
P1 minus mu P2.
The what?
Mean of P1 minus mu
Is that what the
P2.
formula sheet says?
Or what?
Indubitably.
Or yeah,
It's just P1 minus P2.
It just says
Same
P1 minus
thing.
P2, right?
Or it's the same thing.
Because from our understanding of combining random variables, it is the difference of those means. And so you're 100% right on that. But the formula sheet does just say P1 minus P2, doesn't it? Okay. But we know from what we have studied in the past that the mean of P1 hat minus P2 hat, so the mean of that, of all the differences, is equal to the difference of those two means. Okay? And then we just rewrite it using P1 and P2. Now, what should we do to find our standard deviation?
Either do variance or follow the formula sheet.
So there is a formula sheet for sure, but what is the variance thing you're talking about there?
Square them and then add them.
So remember, can I add or subtract the standard deviations?
No.
Okay, you have to use the
Variance.
variances. You have to add and subtract the variances. And do we add or do we subtract in this case?
Add.
You always add.
You always add. Chaos always what? Increases.
Entropy.
That's it. Chaos always increases. Variability always increases. You always add your variances. Now, there is a formula, and I would use that formula for sure, but we want to notice that the standard deviation is the square root of p times 1 minus p divided by n. So what would the variance be?
So that without the square root.
Right. So it is just variance hat minus p2 hat is the square root of, nope, not the square root, the whole thing was that we squared it. P1 times 1 minus P1, all divided by N1. Notice I do have to use an N1 because they could have different sample sizes.
In this case, can you just do it over 50?
I would, at this point, substitute everything in. So write it again, or you could have just put it in. So what is P1 again?
0.25.
0.25. So what is 1 minus P1?
0.75.
Okay, and I will point that out. I usually don't do the 1 minus, I just write the complement. Do you notice that's what that is, the complements, right? What's the sample size? 50. P2? 0.22 times 0.78, all divided by 50, okay? What do I need to do after all of that?
You could just square the
Add in the
previous
square root of the whole thing.
square deviations and add them.
So, square root all of that once you add them. So, that's it.
I think that's it.
So what's my spread?
0.0. No, not that.
What is it?
It's 0.084746.
I trust you.
Well, I'm checking it.
I'm not. That's not what I'm doing.
Thank you when it says that.
What?
Really?
I'm not.
Are you sure?
You sure?
Oh my god.
Oh my god.
That's wild. I mean, I could have less personality if you would like.
Try speaking like monotone this whole time.
Yeah, you should.
You.
I totally wouldn't fall asleep.
That's so funny.
I try to keep people like Jaden awake no matter what. Anyways.
So you should.
What? So there's our standard deviation. Now again, is that what we predicted?
No.
Not even close. Why was our prediction so far off? Variability, law of large numbers was not satisfied. If we had lots and lots and lots and lots of samples, then it would work. Does anyone know, by the way, why I made sure we had a sample size of 50?
Because it said so on here.
To make it easy to do the math.
To eat more M&Ms.
That's fair. That's a good joke assumption, though. How about this? If I didn't use size 50, what would happen to our sampling distribution?
It would
What would it not
It
be?
wouldn't be
Lower.
approximately normal,
It would no longer have been approximately
because the
normal,
log,
'cause
counts.
large counts. I almost did a much lower sample size so that we could do multiple samples, but then I realized if I did a lower sample size, and those are my true proportions, then that would not work out very well for our statistics, right? It would not be approximately normal, so that's why I did that. Alright, but I need us to practice one question, and then y'all got to check your understanding on your own, so that we can talk about means today, but I and Ms. Kowalski totally did this. Calculated difference between proportions of 0.1783 from our samples. What I want you, so what that is saying right here, and I need us to be clear on this. So I did the plain, Ms. Kowalski did the peanut, and when you did the difference in those two proportions, we got a 0.1783. We want you to calculate what is the probability that you get that difference or higher. So P1 hat minus P2 hat is greater than. So what's the probability that that difference is greater than 0.1783? Now, what do we have to assume to be true?
The condition is the same?
Well, we've already checked the conditions, but what would, trying to find the words I'm looking for.
You did eat all the orange M&Ms out of it.
No. We got this sample proportion, but what are we assuming our population proportions are?
Size of the log, or the large counts condition. Bigger than 50.
It is 50.
I'm assuming that these are my true parameters.
Right.
Sorry, that was unclear, that's my fault.
Yeah, I said the condition is
When
the
it
same.
says right here, purely by chance, we're saying, hey, assuming that that is true, what is the likelihood that I get this statistic by chance alone?
What's the line?
Okay, so I need y'all to work with each other. I need y'all to keep this in mind. Now remember, how many distributions are we gonna draw or actually deal with? I have two populations, but how many sampling distributions? One. What's the mean of that sampling distribution? 0.03. What's the standard deviation? 0.0847. That's why we calculated those separately. So I need y'all to work with each other to find that probability.
0.17 is
Right? Doesn't that feel like a lot? We're going to talk about it. Why I did that. That's what you don't do. You know, the first thing I would do, I might convert that number to something. Any ideas what I might convert it to? To what? A Z?
Score.
Z maybe? It's like you're dealing with all these hideous numbers, right? So what could make your job easier if you make it? What kind of number are we going to convert this to? You tell them.
Wait, what's the standard deviation again?
Remember that's what's in the bottom left over there, 0.0847.
How would
Oh,
you,
that's what. I thought that was.
What's up?
how would you write down this thing?
So remember, standardized test
I mean, like, I have
statistic.
this, but like,
How would you write it? Yeah. So,
like as.
How much do you want us to round?
don't round it all until the very end. You don't have to. Okay, two things. Well, let's pause for a second. Y'all can go back to your calculations in a second. Serena asked, how would I ask you to write this equation out? I first want y'all to see this. When you have two populations like this, two proportions, what's your statistic going to be?
The mean,
Oh.
both, the mean
Remember
of
the statistic.
both of them. Wait, what?
The statistic.
Oh, the
It's the
proportion.
one that.
So it's P1 not yet, hat minus P2 hat. Whew, there we go. So there's my statistic. Now go to your formula sheet. Looking under that, we'll talk about that in a second. What do we see for our parameter for when it's P1 hat minus P2 hat? Yeah, it says mu of P1 hat minus P2 hat, but what does that equal?
P1
P1 minus P2. So my parameter, P1 minus P2. Yes, Sanaya?
Do you have an extra formula sheet?
I can print another one out in a second. Divided by, what's the standard error going to be?
0.0847%.
Square root of
All that junk.
all that junk.
Do you have to write all that on the AP exam?
Tell you what, you don't have to, but I guarantee you, if you take the time to write it out, you know it's gonna be harder for you to do? Make a mistake, I know it looks like a lot, and I get it, but also like you're just copying it off of a formula sheet, I would write it out, it's gonna help you not make mistakes. But if you can start with your statistic and you know it's a sampling distribution, you can find the rest of that on your formula sheet. And then you fill in what you need to fill in.
How many FRQs and stuff do we have on the actual AP exam?
So you have 5 normal FRQs, and there's one called an investigative task that I will be printing out for you.
It's not like a long.
Yeah, think closer like a DBQ.
No.
But it's not.
So we haven't even learned all of our resource things that we have to do yet?
How many practice tests do you
Wait,
have?
DBQ?
I'm good.
What is it?
Let's focus on this content for right now.
Okay, but like,
I don't think what I got was right.
what do you get
I got like 56%.
I got
in total?
4.
I would say, what Z
I
score
got
did you get?
0.04.
I got
yeah.
negative
Yeah, so like 400%.
Yeah, that's what I got.
0.175.
So pause for a second. I will go ahead and point this out. It could not be a negative Z.
What the heck did I do?
Because
You put it
this
in
value
0.3.
is bigger than this value, isn't it?
I put 0.3.
Okay, I'll say, so it should be 0.1783 minus 0.03 divided by,
0.0847.
so notice like, you can, and I would personally, if I were you, I would write out that formula and then just substitute everything in, but this is what it gets down to, right? So what is Z greater than?
1.75089.
Okay, now I'll say this, I would leave it there.
I asked if we should.
Hey, hold on.
You gotta explain something crazy.
No, not something crazy.
That's gonna explain.
Look,
I know, I put the answer.
Sanaya, here you go.
I'm about to get it.
So what I would do is
So-
simply this. I would
Wait, so
do
where's
0.25 minus, well, that's easy.
Okay, so this.
I would do square root
So
of
this is equal to-
0.25
so
times
this-
0.75
the
divided by
mean of
50
This would be
plus
equal to just that.
0.22 times 0.78
So,
divided by 50.
uh,
So there's that number, right? Inside the calculator,
right.
right here?
that's the
So
difference.
all I would do is I would take my
Yeah, so
0.1783
0.03
minus 0.03, put that in
Oh, wait.
parentheses, divided by,
Oh wait, no,
and I
hold on.
go up and I
That's not
highlight it, hit
right.
enter.
So you have your
You could just do
value,
answers
your
as well.
Yeah,
statistics.
that's
Right,
right.
but I mean, that's to me easier. You can use these calculators also, like
Oh,
a computer, what's the
Your,
shortcut keys
statistic
for
would be right
command
here.
copy,
and then.
or for
Command
copy?
C,
Command C or Control C, right? So hit Control C and I'm gonna copy that.
So it'd be 0.1783.
Yeah, just press the answer.
Ah,
Control the answer.
Whenever I try to
I
record
just
my
memorized
essays, I always
error, which
delete
is
them.
this whole thing.
Well, I didn't want
That's,
to do like the final, and I could remember like 1.75.
What just happened?
No, 50 is your sample size, so.
Did you press do the numbers?
I think I forgot to,
I didn't.
Yeah,
Yeah,
to the
that
next
should be
line.
this whole thing, and that should be equal to.
You have to press and hold.
0.0847.
it's just Control and C.
Wait. You got 0.4, right?
I got .466.
His is more precise.
Yeah.
I
He copy
did.
pasted
Thank
it.
you.
Okay,
It's just.
alright.
Oh my gosh.
So, what I will remind you is this. If I were you, I would draw my normal curve. I would mark my mean, so I would say P1 minus P2 equals 0.03. We're looking at what, 0.1783? Which we got a Z of 1.75, so we know it's gonna be roughly here. And we're shading to the right. Probability that Z is greater than 1.75, and remember that's coming from that formula, is what? That can't be right.
Wait, Mr. Kenny, yeah, you have.
I typed in the,
yeah.
yeah,
Yeah, cause I got something different.
Way
Yeah, I
different.
have 0.04.
It copied
Yeah,
this
0.
number for some
Wait,
reason.
039.
Yeah, I got it, 43.
Yeah.
Yeah. I just noticed that it copied that 0.08 in there for some weird reason. I
Yeah.
was like, that number does not make sense.
So all that copy and paste.
Yeah.
There you go.
So
Yep,
0.04.
So, let me ask you this. Based on the sample that Ms. Kowalski and I collected and did not make up at all, would you believe the proportions reported by Mars Company, or would you doubt them?
I would doubt because it's under 5%.
Yeah, how likely is it that we get this extreme of a difference or more extreme? Only 4% chance, by chance alone, right?
4%'s pretty good, I'd take my chances.
But on the AP exam, it's less than what, Serena?
0.05.
It's less than 0.05, right? It's less than that critical value. So we would say, hey, I have evidence to disbelieve Mars Company, right? The likelihood of this happening by chance alone, by that randomness alone, is 0.04. Yeah, I don't believe Mars Company. I think they're lying. And by they, I mean, maybe it's ChatGPT.
So there's more orange.
Based on that statistic that we just looked at, we would believe that there is more orange plain M&Ms than peanut M&Ms. Or at least, let me clarify, we at least believe that the difference between them is more than 0.03. Because the claim is that the difference is 0.03, right? That statistic, one, just by it being 0.1783, Serena was automatically like, oh man, that's really high. And I'm like, yeah, it is really high. It's so high, but based on this probability, that I don't believe the difference is actually 0.03. I believe that the difference may be something different. Okay?
Different.
A different difference, that's exactly right. All right. So, big ideas that we need to write down here before we continue to talk about the means. Any ideas what things I want us to write here for 7 point?
Large count. All the combination things.
So, what do you mean by all the combination things?
All the things were like P1 minus P, oh, P hat 1 minus P hat 2, etc.
So, let's make our lives easier than that though. Can we? Is there any way to do that?
For two population samples.
Okay. So, for the sampling distribution of P1 hat minus P2 hat, what do we want to talk about with that sampling distribution? There's three major things.
If they're both approximately normal, then the combination will be approximately normal.
So that is the what of the distribution?
Shape.
The shape, right? Approximately normal if both distributions what?
Are also
So they satisfy
satisfied large counts.
large counts. Remember, that's the one thing you have to remember, and I would either write it out or I would make a note to myself to check both large counts, right?
Tattoo.
Good. They can't call that cheating at all, it's on your body.
Exactly. It's like
Well,
that.
some exams have like a
Please.
stipulation for that.
Or if I wear a shirt with a bunch of formulas on it.
They
There's
would
stipulation for that,
definitely
too.
not.
Just get like a henna tattoo.
Miss Hall won't even know, let's be for real.
I literally talked during the DBQ on English, they did not care.
It's-
Okay, if both of those are greater than or equal to 10, right, then our sampling distribution of P1 hat minus P2 hat, the difference in those proportions is approximately normal. Center?
You guys were so loud when you guys finished like AP-ish. We were
You
still-
guys,
we were
what
still
is the
very good.
center?
AP macro.
Wonderful
we were all-
sheet.
What?
P1 minus P2.
Thank you, P1 minus P2, right? Please write that in there. Trying to find something real quick.
Okay, so we're not gonna do this one.
There's a reason you play and not sing.
Whoa.
You Yeah, I don't think so.
There we go. Yep,
Yeah,
okay, just
we'll
wanna
go
make
with
sure I'm not forgetting. Okay, so the center, mean of P1 hat minus P2 hat is P1 minus P2. The spread or variability. Yo, I got crap to teach.
Three nights suspended.
Hello? Yes, ma'am.
What are your marks?
Dude, if it's Max, gonna crash out.
Yes, ma'am. They go to Miss Granberry and
Okay, no,
Miss
that's
Williams.
fine.
They split.
How about the original?
Someone's missing.
Yes, ma'am.
Chronically.
No problem.
Thank you.
There's a chronic skipper.
Probably. Spread. Standard deviation of P1 hat minus P2 hat. Square root of P1 times 1 minus P1 divided by N1 plus. And again, why is it always plus?
Maybe just be confident now.
You can do that. That makes you happier. You do P2 with a C above it. Okay, that's fine.
Mr. King,
Yes, ma'am?
I know this is not really the time to tell you, but I feel like this is my only opportunity before I forget. I can't come here tomorrow because we have a cosmetology meeting in the cafeteria.
Okay.
There's a lot of people going to that.
Actually, I'm not even gonna rewrite all that. I just wanna, it's right here. Okay? That's the last little bit there with 7.4. But please, I know it looks like a ton, but once again, what does all of this really go back to?
Formula sheet.
The formula sheet of statistic minus parameter divided by standard error. And where do you find the parameter and standard error? On the formula sheet, guys. The formulas are there, it's a matter of substituting those things in. That's the beautiful part about it. It looks like it, you're like, holy crap, that's a ton. But when you just take the time to write this out and then pull the information from the formula sheet, you're good. It's a difference in two proportions, that's all you gotta know. Once you can recognize that, formula sheet's your BFFFF. Okay, I need you to try to do the check your understanding tonight, or I will say this at least, you do need to do the progress checks. So do the progress checks over the check your understanding. If you don't get to the check your understanding, but you do progress checks, I'll be okay. Now, we have actually done everything with proportions. You know what we still gotta talk about?
No.
Central limit theorem.
We do have to get to the central limit theorem, but any guesses what central limit theorem deals with?
I like this.
Well, we've done everything with proportions.
The median,
No, not the median. Maybe the means?
the IQR.
I don't know.
Hey guys, what did we do with the pennies? We looked at the sample proportions, and then we looked at the sample
I don't know.
means. So we've done proportions, now we're dealing with
Means.
means.
That looks like a
Almost like I said
tilde.
it.
I know, but someone's looking at me like I'm crazy.
Where is
Again,
it?
mean and mean.
It looks like a tilde.
What's the next thing in the, oh, ish, hold on a second, I'll explain why. So we're about to look at means, so first things first, sampling distribution of means, what they had from Mathematic was, so just here, I wanna ask this, what predictions do you have about the properties of sampling distributions of a sample mean?
What?
Geometric.
So, when we talk about means, and we're talking about the sampling distribution, of means, right? What do you think might be true of that sampling distribution?
The mean of the sample will be the same as the mean of the population.
So the mean of all the sample means you're thinking might equal the what?
Mean of population.
The population mean, okay?
Yeah, we said that, right?
Any other predictions? Notice this is not p anymore, this is mu, because what are we dealing with? Means. Well, we're dealing with means now, right? Okay, any other predictions that we might be able to make about the sampling distribution of a sample mean? Don't look at the formula sheet. Yes, it's there, don't look there. I want us to think for a second. What else do we think might be true?
Something with approximate normal stuff.
Something about, oh, so we got center and we got maybe shape.
Mm-hmm.
Okay, so when do we think, so we got our center here. When do you think our distribution will be approximately normal?
When the median is.
When the
Large
sample is a
count.
certain size.
Approximately normal when n is large enough, a
Yes.
sample size. Now, so I heard someone say large counts, but a key to large counts is n times what? P. And what do we not have with means? We don't have a p, do we? So we're going to use large counts with
And
means.
it's like, what, like the 10% rule or something?
So remember, that's when sampling without replacement. You said n is large enough, leave it there for now. We'll come back to it, okay? I promise.
Are we
Okay?
gonna like figure out what constitutes large enough?
Yes.
It's the central thinking theorem, whatever.
Yeah, maybe, something like that, yeah, uh-huh. Any guesses on our variability?
Um,
No.
Sarah's last time.
What do you mean by same as last time? There actually is a huge connection to what we did last time.
is it like still over the popular sample, whatever?
Oh, maybe some, so like, here's the thing, we're now gonna look at this standard deviation of x bar, right? The standard deviation of our sample means. What happened last time with the sample proportions? What did we do? Because remember, we had the square root of n times p times 1 minus p from our binomial distributions. So what happened to our sample proportions?
Over n.
We divided by n, right? Any guesses what we're gonna might do here?
Divide by,
Divide something by n maybe?
mayhaps.
Mayhaps. What if we, we'll come back to that in a second. So yeah, maybe dividing something by n. What do you think we might divide by n?
For what?
The mean? Oh,
Well, remember, what are we trying to, wasn't this standard deviation up here?
yeah.
So what do we,
Sounded variance.
so, the variance divided by n.
We're
We
just
have to
gonna
do the-
keep on saying words and how to say the word.
Well, we don't have to, because I want you to think about this. If the variance of our sample means
Which is all about
is the
variance.
variance divided by n, what is the standard deviation of our sample means? How would I find that?
Take the square root.
Take the square root.
Oh my god.
Oh my
What?
goodness.
No way.
So what do we get?
Sigma over
And-
root n.
Alright, go look at your formula sheet for me real quick.
Oh wow, it's stale.
Is that what the standard deviation of the mean are?
Yeah, what the divvy.
But you can't leave a square root as an denominator.
Jin.
That's a whole lie. You know why that people say that?
Because they are annoyed.
No. Because math teachers once upon a time said, hey, it's way easier on us if we standardize it and you have to do it this one way. Mathematicians don't follow that rule. That's a math teacher thing. It's dumb. Most respectfully. He's saying about the idea of not leaving a square root in the denominator.
Oh.
The idea of rationalizing. Leave that square root in the
Maybe it was
denominator.
easier to grade the other way.
No, it is. That's 100% it. It's easier when you standardize and you have to leave the answer this way. But they don't do that in AP Cal. They don't do that in AP Stats. They don't
Yeah,
do
yeah,
that.
no, we can have the
Yeah.
square root and all that.
All that to say though,
Easily.
please understand there's our standard deviation and there's our mean. Once again, based on what we have already seen, the mean of our sample means is just the population mean. The standard deviation of my sample means is the standard deviation of the population divided by the square root of n. And something about the shape is going to be approximately normal if n is large enough. And I want to point this out. I sent y'all the graph of the pennies, right?
Yes.
The pennies, what shape was that distribution?
No, it was skewed, wasn't it?
I was gonna say, I thought it was like wicked skewed. Let me pull it up.
It was very skewed.
It was
left.
skewed left.
That's as skewed left as it gets, isn't it?
Dang, 1950.
Yeah. I want y'all to look at these sampling distributions over here though. Originally, we said it was a little what?
Skewed.
Skewed left, right? Because really probably that mean is here and a little skewed left. Then it was still a little skewed left, wasn't it?
Yes.
But then we get down to here. Is that still skewed left? So why is it no longer skewed left down here? Because our sample size was what?
Increased.
Increased, so it was what? There was something else we
It
said.
was large enough.
It was large enough. It was sufficiently large. That's the language we're going to use. Now, here's what I want you to see. So what predictions do we have? Guess what? You have now covered everything that you needed to cover with 7.5. So I think I put a sheet in there. Yeah, did a whole activity just for this. Did I put it? Yeah, 7.5.
Some like
So quick note.
You'll just use eating like snacks in this class now?
At this point,
Do what?
it's been twice. That's
You're
good.
like a Pavlov's dog?
What's that?
You don't know,
Pavlov dog?
you
Okay.
don't know
so
Pavlov's
It's like
dog?
classical conditioning.
Oh, yeah, I don't know that now.
Sampling, distribution of sample means. Say again?
I think we've done that for that.
With p hat. Well, the reason why we were able
Yeah.
to do it here and hopefully it made sense to us is because we did all the work with p hat. Okay, so sampling distribution of sample means. So one, I'm gonna say this. Do not leave off shape for now. Don't put shape on there, okay? I'll explain why in a second. So sampling distribution of sample means, but let's talk about center. The mean of all the sample means is what? The population mean, okay? The variability, the spread, the standard deviation of all the sample means is what?
Mu over square root of.
So population standard deviation divided by the square root of n. We're going to come back to that detail about shape later. And over here, remember you're going to have some mean in here. And we're going to have some kind of z. And so how am I going to calculate z this time?
Anyway,
Let's start at the very beginning.
Inverse normal.
statistic minus
I'll say z, so you're thinking if you're given an area, Serena, but I'm just saying in general, how are we going to calculate it? Statistic minus parameter divided by
standard error.
standard error. Remember, that's all on that formula sheet. And if we're dealing with sample means, what's the statistic going to be?
X bar.
X bar. So z equals x bar minus mu divided by,
Standard deviation.
so
Standard deviation of X bar.
yes, standard deviation of x bar, but what's another way to write standard deviation of x bar?
Standard deviation over square root of n.
There you go. That's it. Notice that is the mean of my sample means. That is my standard deviation of the sample means, right? Statistic minus parameter divided by standard error. And then you do the probability that z is greater than or less than whatever value you calculate. Okay?
Can I use the restroom?
You're never allowed to use restroom for the rest of your life, so that's the second one.
That sounds like such a hard life.
Yeah, you can go.
Thank you so much.
Ah, I knew there was one thing I was forgetting. What's one thing we always need to remember with this formula? Anyone remember?
Variance.
You can only
You
add
don't need
it.
to.
Well, we only have one.
Yeah.
Oh, no,
Yeah.
10%,
If all large numbers
10%.
is that is, wait.
What'd you say?
10%.
Right. If, whoops, I should say sampling without replacement. Check 10% condition. So keep that in mind. If you're sampling without replacement, you gotta check that 10% condition for that standard deviation. That standard deviation formula does not work if it violates the 10% condition. Okay. So, now let's look at the last pure content that we've got to learn. For the sake of time, we've got 12 minutes. I usually really like y'all to explore this on your own. We don't have time. So, what I'm going to do, and you can do this on your own time to play with it, but I'm going to show you what is happening. So, the website is actually on the previous page. Go back. This is on the page before the notes you just took. So what does it say, online stat book?
Yeah.
I don't see this stuff.
It's right before the page.
Pieces. There you go. So online stat book, I'm gonna hit begin. And so notice, what type of distribution am I starting with? The population is a what?
Approximately normal.
It's approximately normal, right? And so I am going to do a sample size of 2, okay? And I'm going to animate this, so you notice it has 2 pieces, That, what do I call this distribution right here? This is a
Sample.
sample distribution, right? Each data point is constituting a sample. Then this is the statistic from that sample.
So sampling distribution.
Yeah. So you can see how I'm creating a sampling distribution here. Any guesses what shape this distribution will have?
Approximately normal.
Now, earlier you said the sample size has to be sufficiently large, didn't you?
Yeah, well, if you keep on going.
Well, now remember, what is my sample size here?
Oh, it's too small.
It's 2, it's only 2, right?
Yep.
Okay, well, let's jump ahead. Oh,
Yeah. Okay, so you.
I never said you were wrong.
No, wait.
But I want you to understand, you said earlier that n has to be sufficiently large, right?
Yeah.
Okay, so let's try this again. We're gonna go with a sample size of 5 this time, okay? And I'm gonna animate a couple, so remember, notice, right here is a sample distribution, or distribution of a sample,
See.
okay? This will become a sampling distribution. Whee! That is taking way too long, and it is approximately normal, but what's different this time?
The
spread.
variability.
The
spread.
The variability is less, right? The spread decreased. Does anyone know how much it decreased by?
Well, how much did you increase it by?
Yeah, that's the tricky part. Technically, I increased it by a factor of 5 halves. So it'd be the square root of 5 halves is what it was decreased by. I know it's funky, but that's because I went from a sample size of 2 to a sample size of 5. Okay. So what happens if I go to a sample size of 20?
Well,
Decreased by 4.
Screwed it
it's
in.
gonna get even, it's getting all.
It does. Notice, does the center change at all?
No.
No, this center is still the same as this center. And it's hard to see. Actually, I can make it larger. Duh.
You cozy, Jalen?
So notice right here, this mean is 16, and what does this mean?
6101.
6101. Why is this not exactly the same as this?
Variability.
Right, that's sampling variability, right? But if I continue to sample, what is this going to approach?
16.
The value.
Alright, so it'll approach that. Alright, now we get to see some fun stuff. Okay? What if it's uniform? Okay, so there's my uniform. Notice there's a mean of 16, a standard deviation of 9.52 while Serena's being nice and not distracting.
Oh, okay.
And then I'm going to do a sample size of 2 this time. Notice there's 2, there it is. Whoop, there it is. Alright, now I'll do 100. What shape do you think this is going to have?
No, uniform. Yeah.
Whoa,
Whoa, that's
pyramid.
I was saying, is that going to be approximately normal?
No.
It's symmetrical. Why not approximately normal?
Yeah.
It's not bell.
It's not bell curve. It does not look like it's going to satisfy. It's going to be following the empirical rule, right?
Why does it do that?
That's a good question. Well, so here's the thing. Remember, if we're pulling one from here and one from here, what's the average of those two? It's going to be right in the center, right? So we're going to have more in the center than we're going to have on the edges. It's very rare that we're going to have 2 data points all the way from out here, right?
Yeah.
So now what happens if I change my sample size to 5?
It's gonna get usable.
So notice I'm doing 5 at
Less
a time.
spread.
It is less spread. But what is it closer to now?
Approximately normal.
Oh, it started to become bell curve, didn't it? Approximately normal, less spread. Cool, 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 cool. What about if I do n equals 20?
Oh boy.
Burj Khalifa.
What does that look like to you?
The first
Very
place.
much pretty.
Oh, it's approximately normal.
First place.
Okay. All right.
You say the bridge.
Y'all ready for the really fun stuff?
No.
No.
You-
That's okay.
You just make it down in shape.
No.
So are you just making a point that no matter what, eventually it's gonna become approximately?
Yeah, if the sample
Yeah,
size.
So
you
look,
felt
I
this
got.
trend.
Oh wait, if the sample size is what?
Fell for his trend.
Oh, if the sample size is big enough, what's it going to become? Approximately normal. Now notice, if I do a sample size of 2, is that approximately normal?
No.
No, that's skewed right, and it's even bimodal, right? Dun, dun, dun. It's because this had a gap, it was almost bimodal. Not always. What if I go to a sample size of
100.
5? That's still skewed right, isn't it?
Yep.
Okay. What about 10? Still skewed right a little bit. Okay. That's getting there, okay? So here's the thing I want us to notice, and this is why I did not use what the Mathematic had. I just want us to do quick notes. So, and this actually goes back to 7.5. I should write this down first. So, sample means, what about the shape? What was the first thing we noticed? If population is approximately normal, then what's going to be true for the sampling distribution? Yeah. Does it matter how large the sample size is? No. If the population is approximately normal, the sampling distribution for any n is approximately normal. So we want to recognize that if your population is approximately normal, hey, that sample size, or the sampling distribution is going to be approximately normal. For the means at least, right? Give a second for you to finish writing that down. Michael must be Speedy Gonzalez over there, already done.
Yeah.
So cold.
Seriously?
No, it's freezing.
Like it's actually.
Yeah, you can turn it up a little.
Like, look at Jaden.
No.
His arms fell off.
Hold up.
Okay,
Whole leg was chopped off. Whole arms were chopped off.
I'm gonna temperature up a little bit. Alright, so,
310.
Anyway.
you could have said something
That
earlier.
stinky shirt.
I was thinking
Every
about
time we say something, you say you should dress better.
I don't.
Are you so serious? That's definitely so.
I miss when you could bring a blanket.
Right.
Dude, bring a blanket was so
See,
elite.
I would bring a blanket.
All right.
I would
Really,
carry
blanket?
around.
So,
Yes, bro.
It's
They
not
made that like
very
freshman
people.
year.
We should keep it on our
Are you so
side.
serious?
so, okay, so right here, hey, listen, guys, listen, we have now finished after this, everything but one lesson in mathematics, which is just the difference in two sample means. So you need to be prepared for a DYU tomorrow. That's why we're doing those progress checks. I have already opened up the last progress check if you want to use that to prepare for your DYU. But
Oh boy.
if n, what do I mean by n again? If the sample size is sufficiently, what? Large, what's going to happen?
The sampling distribution will be approximately normal.
Which type of sampling distribution are we talking about?
Sample mean.
Yeah. So keep that in mind. This is sampling distribution of sample means,
So
or of a
that's
sample mean. Yep, x bar. Is approximately normal regardless of the population distribution. Okay, now no one's asked a question that I'm really surprised we haven't asked.
Are we there yet?
You said population distribution, but then you wrote shape.
Oh, population distribution shape. What's the question that should be gnawing at us?
What's the theorem, or like what's the formula?
What's the central limit theorem?
I mean, that's the central limit theorem, and that's why I want you to hear me close. No, this is important for the AP exam, because I used to not teach this the right way. The central limit theorem says if n is sufficiently large, the sampling distribution of a sample mean is approximately normal. Yes?
How large?
There we go, thank you. That's a good question, you can get some
I'm not
candy
talking,
later.
I just didn't
Okay,
think it was
then you should have
important.
said it. Okay, listen, that's the actual central limit theorem. The real answer is usually a sample size of 20, notice those pennies over there that was heavily skewed, is approximately normal. Usually a sample size of 20 to 25 is enough. What the AP exam uses is 30. But please understand, the central limit theorem does not say that n has to be greater than or equal to 30. The central limit theorem says n has to be sufficiently large. That's the language you have to use on the AP exam. that the n is sufficiently large. And then you can compare it to 30, but the AP exam, the real central limit theorem says n is sufficiently large.
So are you gonna use 30 like the AP exam?
Say again?
Are you gonna use 30 like
Oh,
the?
Yes.
Alright.
Yeah, yeah.
This is the AP exam.
Yeah.
X, 5.
But notice, has our z-score formula changed?
No.
Nuh-uh.
You're taking my students.
Oh no, how will you ever survive? Okay, so I'm showing that's a sampling distribution, and then we'll still do that detail. So, we are going to do 7.7 tomorrow and a demonstrated understanding. We'll do a little bit of practice as well. But again, I need y'all to hear me on this plan. 7.7 to help us practice with some of these ideas and also talk about the difference in sample means. DYU, then we'll go over it, do some more discussion, analysis, help each other grow and learn. We may not be completely ready for the DYU. That is why I will take your test this time for sure and replace your demonstrated understanding grade, so treat it as a learning experience. Study for it so you're ready, but treat it as a learning experience. And then we're going to review on Friday just a little based on your questions, based on the progress checks, and then test it on Monday. So you have still the weekend to study. But Friday we are starting the next unit.
But also,
Say again?
the top checks there.
Yeah, sure.
Like actually like step up, starting at.
Can I come back here?
Like me and Serena, I have to go to this one.
I have to leave soon though.
It's 1/P.
Wait, when do you have to do?
That stuff.
By
I've been
3:30.
to like
And it's whenever
How do you
we
stop?
all the
until
past
success.
meetings, nobody's
Okay,
there.
so
I get it.
wait until success or until
The
failure?
grave.
Don't sit down to that level.
It was a while ago. Until success, not until failure.